Hello, awesome students. This is Bert Dixon here presenting on lesson 9.2. Please go ahead and open up your geometry book to page 433, and we'll go through some of this material together. So in section 9.1, we learned several properties of parallelograms. So if you know a figure is a parallelogram, then it has properties such as the opposite sides are congruent, the opposite angles are congruent, the diagonals bisect each other, consecutive angles are supplementary, and so on. So there were many properties that you learned in section 9.1. In section 9.2, we're going to look at it the other way. We're going to see what information do we need to know about a figure to decide whether or not it's a parallelogram. And so we're going to be looking at a lot of the converses of the theorems that we learned yesterday. So for example, yesterday we said, if a figure is a parallelogram, then its opposite sides are congruent. And in this theorem, it says if opposite sides are congruent, then the quadrilateral is a parallelogram. And this is pretty easy to prove using congruent triangles. If we know that opposite sides of this quadrilateral are congruent, all we have to do is draw a diagonal. That's a shared side. And then we can say these two triangles are congruent by SSS. And if they're congruent, then all their matching parts have to be congruent. So angle 1 and angle 2 would be congruent. Angle 3 and angle 4 would be congruent. And so that's enough using alternate interior angles to show that this line must be parallel to this one, and this line must be parallel to this one. So now you see again why we spent so much time on congruent triangles, because understanding how to prove congruent triangles helps us prove a lot of other important things in geometry. Like in this case, it helps us prove that the quadrilateral with two pairs of opposite sides congruent must be a parallelogram. Okay, and then on page 434, another converse. Yesterday we had some theorems involving opposite sides and angles of quadrilaterals. This one says if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So what that looks like, it's a little bit different than the one we just looked at. We have one pair that is parallel, and that same pair is congruent. So you can kind of imagine how you would go about proving that. Again, if you drew a diagonal, then that would be a shared side. And because of the parallel lines, we have alternate interior angles that are congruent. And so then we end up with these two triangles being congruent by SAS. And that makes them angle 1 and angle 2 congruent by corresponding parts of congruent triangles. And that would then be enough to say that these two sides would have to be parallel by the converse of the alternate interior angles theorem. Okay, so again, congruent triangles really helped us out with that. Then we also have a theorem that says if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So that is definitely a converse of one of the theorems you learned yesterday, or in section 9.1. Section 9.1, we said if a figure is a parallelogram, then its opposite angles are congruent. Here we're saying if opposite angles are congruent, then it must be a parallelogram. Okay, and so they kind of walk you through the steps there on how you would go about proving that. And then we also have a theorem that says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Again, that's a converse of what we learned yesterday. And I'm going through these kind of quickly because I'm going to summarize them all in the end. And then let's go through on page 437. Let's go through examples for A and B. So in example A, it says show that each quadrilateral is a parallelogram for the given variables. So if you plug in x equals 7 and y equals 4, if y is 4, then this side is 16, and this side is 16. And if you plug in x equals 7, that's 21 and 21. And so now we can say, since opposite sides of this parallelogram are congruent, then the quadrilateral must be a parallelogram. Okay, same idea for problem B. If you plug in z equals 11, we get this angle would be 118 degrees. And then this angle would be 121 minus 3, which is also 118. And then if W is 4.5, 14 times 4.5 minus 1 is 62. And then this one, 12 times 4.5 plus 8 is also 62. And since opposite angles are congruent, then the figure must be a parallelogram. So angle F is 118 degrees. Oh, what they wanted here was 9 times 11 plus 19, and that was 118. This is 11 times 11 minus 3, which is also 118. For angle E, it's 12 times 4.5 plus 8, which is 62. And then 14 times 4.5 minus 1, which is also 62. So the measure of angle F equals the measure of angle H, and the measure of angle E equals the measure of angle G. EFGH is a parallelogram since both pairs of opposite angles are congruent. Okay. And now I'd like you to go ahead and pause your video and try problem number 6. Press play when you're ready to confirm your solution. For problem number 6, if A is 2.4, then this side is 16.8. Let me see if I get a smaller pen here. 16.8, and 2 times 2.4 plus 12 is also 16.8. So both those sides are congruent. And then this angle Q is 10 times 90, that's 90 minus 16, that's 74 degrees. And angle R is 9 times 9, that's 81, plus 25 is 106. Okay, and so what we have is, we have 74 and 106, those are supplementary. So same side interior angles are supplementary. That makes these two lines parallel. So now we know that QP and RS are parallel. So we can say QP is congruent to RS because they both have the same length, 16.8, and also QP is parallel to RS. And so we can say, since QP and RS are both parallel and congruent, then PQRS is a parallelogram. Okay, now I have kind of a summary of everything that we've talked about so far in this lesson here, and you can pause your video and write all these down if you want to have them all in one place instead of on multiple pages. This is just a summary of what we went through in the textbook. So if both pairs of opposite sides are parallel, then it's a parallelogram by definition. If both pairs of opposite angles are congruent, then it's a parallelogram. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. Diagonals bisect each other. If one pair, this is like the example we just did in problem 6, if one pair of opposite sides are both parallel and congruent, then it's a parallelogram. So that's one pair that has to be parallel and congruent. That makes it a parallelogram. Or if both pairs of opposite sides are congruent. Okay, so those are 5 different ways that you can show that a quadrilateral is a parallelogram. Okay, so to get a little bit more practice, go ahead and pause your video and try problems A through F. And after each one, if you say it is a parallelogram, then tell which reason. So you can say by reason 1, reason 2, reason 3, reason 4, or reason 5. Okay, so pause your video, try those out, and then press play when you're ready to see the solution. Okay, so for problem number 1, this is not enough information to conclude that this is a parallelogram. It might be, but we don't have enough information to use any one of these 5 reasons. So we'll say might be, but not necessarily. A parallelogram. Okay, B. Here we have one pair of sides congruent, another pair of sides parallel. Again, not necessarily a parallelogram. Okay, just to demonstrate, it could be a trapezoid. We could have an isosceles trapezoid like this, where these 2 sides are the same, these 2 sides are parallel. That's definitely not a parallelogram. Okay, for C, we have both pairs of opposite sides congruent, and so yes, by reason number, let's see, which one says both pairs of opposite sides are congruent? That's reason 5. So yes, by reason number 5. Part D, both pairs of opposite angles are congruent, and that is reason 2 on our list. So yes. By reason 2. Part E. So we have one pair of sides congruent, and since these are, they're not congruent, but they're supplementary, that means these 2 lines must be parallel. So now we have one pair of sides that are congruent and parallel. And so that goes back to reason 4. One pair of opposite sides are parallel and congruent. And so that's what we have. So that was reason 4. So yes, by reason number 4. And then problem F, our diagonals are cutting each other in half, so that length and that length are the same, that length and that length are the same. They're all 4 the same in this case, but they don't have to be. Even if I gave you a diagram like this, and I said this was 8 and 8 and 6 and 6, that would still be a parallelogram. because the diagonals bisect each other. And so that is reason number 3. If the diagonals bisect each other, then it's a parallelogram. So we'll say yes. By reason number 3. Okay, and that's it for today's lesson. Go ahead and try the assignment for section 9.3. Have a great day.